This is Dave Benson.
Hi, I'm Dave Benson, K1SWL.
And this is my build of his latest QRP CW transceiver. He presented it at 4 Days in May 2021. My transceiver has a universal VFO controller on the front with a liquid crystal display. It's built on 2 circuit boards. The lower circuit board has the transceiver, the receiver and the driver in the transmitter, and the upper circuit board has low pass filters and a high pass filter. And all of the controls, just for something different, come in and out on the right hand side. Now let's have a look at the version of this very interesting rig from Dave Benson, K1SWL. Let's have a look at the variation that I've come up with. So starting with the receiver, I'm using an MAR3SM. This is a MMIC that I had available, and it has about 8 dB of gain, and then into an ADE1. So apart from substituting the specific MMIC there, this is exactly as per Dave's design. Because I wanted my transceiver to be multi-band, I have omitted the low-pass filter on the local oscillator, because if you add low-pass filtering in, for it to be effective when you're spanning a number of bands, you really need to switch the low-pass filters, and that just complicates band switching. So a bit of a compromise there, but I've left that off. I made the pad on a socket so that that facilitates a degree of adjusting the receive gain. So it's easy just to start off with even a short circuit there, so a 0 dB connection, and then this point can be padded as required to get the receiver gain right. Dave did mention that on 20 meters and above, the gain could be a little bit light, and I was really keen to try this receiver out on 20 and 15 meters. And so I decided that I would add a second MMIC. So I have an IF stage before and after my crystal filter. And I used MAR6 MMICs, again mainly because I had them available. These can do around 20 dB of gain. So they're much hotter than the MAR3s. So I'm hoping that the gain will be right as we move from, let's say, 80 meters, where I want this receiver to start, up to 15 meters. Everything else about this part of the IF is the same. I've used the same L matches, the same intermediate frequency, but I just have a second gain stage. Because I've got extra IF gain, I'm careful to put an extra pad in here. Again, having pads sprinkled through the IF strip like this, just give you some freedom to control the receiver gain. During testing, you can just short that out, or you can pad it up or down, more or less padding as required. The product detector with the SA612 is as per Dave's design, and I've also elected to use a 4.915 megahertz BFO crystal, and that just removes a reliance on a SI5351 BFO, so that the only SI5351 clock in the receiver is the VFO. And I have found experimentally that receivers can be a little cleaner, a little freer of spurs and spikes if you take this approach. So then the audio output comes down to this filter chain. So here's the high pass filter with its DC offset, and then 2 stages of low pass filtering, then the gain stage, then into the series FET. And while a J113 was specified, I didn't have any of those, and so during my experimentation I dropped in a 2N5485, and I'll report on how that is working later. And then off to the volume control and side tone couples in at this point. Although I was most intrigued by by Dave's choice of this NJM2113 set up for 0 dB of gain in his audio amplifier. I didn't have one of those and I couldn't get one quickly. And I must admit I fell back to old habits and I've built in an LM386. Now, whether or not this is a good choice remains to be seen. This is going to have quite a lot of gain, particularly with this 10 microfarad capacitor. So I'm not expecting to get clean break-in, but by reducing or removing the 10 mic capacitor and potentially by damping down the gain of this stage to something quite low, I might be able to get some success with this LM386. And if it all fails, then I will revert to an NJM2113 audio stage once I can source one. So coming back to my schematic for my version of Dave's transceiver, here's the antenna socket. The antennas go into one of the 4 switched low-pass filters, and I've got them here for 80, 40, 30, and 80, 40, 20, and 15 meters. For the receive path, then through this high-pass filter here with a cutoff of 3.4 megahertz. Transmit receive switch. Now Dave didn't use this. I've pinched this from other sources. Actually, I've pinched it from the Hans Summers QCX, and it's a series BS170 switch that switches between low pass filters and the receiver input or the high pass filter. This is the extremely simple CW transmitter. The driver is a 7408, a quad NAND gate, and it drives the 3 parallel BS170s, which have an output transformer, and NDT452A does the DC switching, so that when transmitter is enabled, 12 volts is placed onto the drains of the BS170s. That concludes the walkthrough of the schematic. In other videos in this series, I'll demonstrate the transceiver in action and talk about some of the design and construction challenges.